A equals 3, 6, 7, 8, and B equals 5, 7, 9, 10. What is this symbol? Or and union. Both are correct. I was actually looking at both of them, and you answered both of them. Now, how do we know it's union? Well, first off, our formula sheet says it's union, but secondly, we know it's or because if I go to write this as and, it looks stupid. So it's or. And or means more, correct? So if it's an either or, we are listing it. So 3 is in 1, 5, 6, 7, 9, 10. So we need 3, 5, 6, 7, 9, 10. 3, 5, 6, 7, 9. Is there an 8? And an 8. 9, 10. So it would be D. Some people pick B because they think if it doubles up, we just don't list it. Doubling up's fine, right? You just list it once. So if it's an either or, you list it. The next one says P is 2, 4, 8, 16. Q are the factors of 6. So it multiplies to give me 6, which is 1, 2, 3, and 6. And R is 4, 8, 12, 16. Which pair of sets are disjoint? Disjoint means what? Nothing in common. There's nothing that overlaps. There's nothing that's the same. Okay? Are there any that have nothing the same? So I see if I look at P and Q, they have a 2. So that's done. If I look at R and P, they have 4, 8, 16. So they have overlap. If I look at Q and R, I have 1, 2, 3, 6. Here I have 4, 8, 12, 16. Is there any overlap? Anything that's the same? So how do I know if something is disjoint? If I take those two letters and I find the intersection. So if I go Q and R, what do I get? Nothing in common, so what do we put in there? Do you remember? Empty set, which is the 0 with the line in it. So if when I take the intersection or the and of two sets and I get the empty set, they're disjoint. So it's Q and R. The next one gives us the U, the universal set. The universal set are the only numbers I have in my hat, right? So I take 1, 2, 3, 4, 5, 6, 7, 8, 9, I put them all in a hat, and those are the only options I have to make subsets of it, correct? That's the universal set. So I made a subset out of this hat of M, and I took a 2, a 3, a 5, and a 7 out, correct? Then I went to N, and I pulled a 1, a 3, and a 5 out. Could I take a 10 out if I wanted to? Could I put 10 in either of those sets? No, because the universal set is just the natural numbers from 1 to 9. Okay? So I want the intersection. Intersection, if you forget, is this symbol, and that symbol I can actually write the word and out of it, so it's and, correct? So I want what's in M and N. So what's in both, correct? So what numbers are in M and N? 3 and 5, which is A. If I wanted or, what would it be? 1, 2, 3, 5, and 7. If it's in either or, I would list it, right? So you get more when you have more. Okay, what does this little n mean? Number of elements in it. So I could say number of elements, or they could use an n. They often just write the words numbers of elements in. And the reason why we did this, I told you, is it comes up so that you can fill into a numeric response box. Because if my answer is like 6 numbers, I have 4 boxes to fill in, right? So they can't ask me to do it by filling in the actual numbers. I would have to find the number of elements in it. So here it says n. What does this little thing mean? Complement. Remember, it's not in it. So it's here, complement. It's on our formula sheet. So it's a complement of n. So it's what's not in n, but in the what? Universal set. Okay, so in n we have 1, 3, 5. The complement of n would be 2, 4, 6, 7, 8, 9, and I have to make sure I do the squiggly brackets. Now, if I take n and its complement, and I find the union of it, or the or of it, what should I get back? I take n and its complement, and I find the union of it, or the or of it, what should that give me? Yeah?
Nothing.
The and would give me nothing, so they would be disjoint. What would the or give me? Yeah?
The universal set.
The universal set. So you're completely right, because the next question I was going to ask is what would the and give me? So complements are completely opposite, correct? So if I said n and not n, you would get the empty set because they're complements. There's nothing the same, correct? But if I said n union not n, then you're right. I would get the universal set back, right? Because the complement should give you the universal set back if you use or, because if it's in either or, it should give you the universal set. So I want the number of elements in not n. Well, that's 1, 2, 3, 4, 5, 6. I always fill the numeric response left to right. If you're filling in the right box, you are wrong. You have to fill in the left to right, and you don't have to fill in all the boxes, correct? So I fill in a 6, and I'm done on the very far left. This one here says, use the following to answer the next 2 questions. Factors of 16, or what multiplies to me 16. So it'd be 1, 16, 2, 8, and 4. Because 4 times 4 gives me 16, right? Do I have to list them in order? No, I can't take marks off. It's easier if you do. I can't take marks off if you don't list them in order. Factors of 8 would be 1, 2, 4, 8. And then even numbers less than 10, does it tell me where I stop? Technically, no. So I could do -2, 0, 2, 4, 6. But I do have to stop at 8. Technically, right? So this one here says, what is in set A or B? In A or B, I have to list anything that's in A or in B. And how do I know this is an or? Because it says or is like this, a union, correct? So if it's in A or it's in B, I list it. Or means more. So 1, 2, 4, 8, and 16 are in A or B. Now this one wants the number of elements, right? In A and B and C. These are ands because I can write the word and out of them. So it has to be in A and B and C. What numbers are in A and B and C? What do you get?
1, 2, 4, 8, 16. Oh, and 2 and
it has to be in A and B and C. So which numbers are in all 3 of them?
2, 4,
2, 4, and one more.
8.
8. Perfect. So how many is that? 3. Now remember, it's really easy to miss a number, right? It's really easy when you're going through to miss a number, especially if you're looking at 3 sets. So just triple check. Okay? Here it says, if the universal set of natural numbers, if the universal set of natural numbers, we naturally start counting 1 as a child. 1 onward, correct? So natural numbers are 1 onward, and whole numbers are the natural numbers and the one with a whole. What's the number with a whole? 0. Okay? So we want the complement of multiples of 3. What the heck is a multiple of 3? Starts at 3, goes up by 3. So 3, 6, 9, blah, 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 blah. So those are the only ones I'm not going to have out of the natural numbers, right? So it's going to be 1, 2, not 3, 4, 5, not 6, 7, 8, etc. Because it wants the complement of the multiples of 3 in the universal set of natural numbers. Complement. Some people just bypass this word. Okay, we have to read all the words. Complement means not multiples of 3 in the natural numbers. Okay, we're going back to notes. So we are here. Remembering what we talked about yesterday on a 3-circle Venn diagram. Everyone's paying attention. No one is sidetracked on anything that isn't a phone. If you're on a calculator and we're not calculating anything, you're playing Tetris, and I know it, so don't do it. All right. So, what shape is this? It's an eyeball. Remember my great artistic abilities? The eyeball appears on the Venn diagram right here, correct? What does that mean? What's the eyeball represent? Intersection and. Now remember, we also have the shape of the snowman. That's a terrible head. Oh gosh, my drawing ability is decreasing. Sideways snowman is not where I'm rolling at here. There we go. There's this. That's his scarf. It's really great. Okay, the snowman. What does the snowman represent? Union or, right? Oh, wait a little. Bird box. Okay. And then these are the singles. So this would be just, for example, A. We'd have to do the whole thing, correct? The crescent moon, however, so if I just want this part, this is A. That would be this piece, right? So that's A without what? B. No B involved, correct? So how we write that is A and not B. Remember when you have the crescent moon? It's I want A but not B. I told you could say but not instead of and. Now what if I had the crescent moon of B? Okay, this is my B. This one would be B, that's an eraser, B and not A, correct? That's the difference. So this is a fancy way of saying B only. And this is a fancy way of saying A only. It means the overlap I'm not counting, right? All right, so let's go back to our notes. So here it says the diagram displays the number of students who are members of student council, S, and the students who are on the yearbook committee, Y. How many students are on student council? Does it say student council only? Is the word only appearing there? No, it says student council. Do we care if they're also on yearbook? No, we just care if they're in student council, correct? So some people will tell me the answer is only 12. It's not. That's the people who are only on student council. I want all the student council kids. So how many is it? There's 2 and? There's 3 and how many? 12, right? There's 3 in student council. They happen to be on yearbook. Don't really care. And 12. So it's going to be 12 plus 3, which is 15. If they ask for student council, I state if they're on student council. So they're on yearbook, too cool. That doesn't really matter. I just want all the ones that are student council. Those 3 in the middle are on student council and yearbook. They're called overachievers. That's what they are. Just kidding. It's funny. No one laughed. I wanted to smile. Thanks. Anyways, the people on, I was on both of those because I'm super cool, guys. Trey, cool. I don't know what cool is, not a false thing. Anyone know what cool is? Trey. Very, very, very cool. Okay. All right. On both student council and yearbook, what symbol is and in the Venn diagram? It's going to be this symbol, and in the Venn diagram it is what shape? The eyeball. So I go directly to the eyeball and I say, how many is there? How many are in the eyeball? There are 3. You guys aren't trusting yourselves. I know you all will answer 3, but you're like, I'm not going to say it just in case it's wrong. Okay, the next one says, on the yearbook committee, but not student council. What's other fancy way of saying? Yearbook committee, but not student council. Yeah, so just the yearbook only. Yeah. So not in the student council. So this would be yearbook only. So if I say yearbook but not student council, that means I want all the yearbook people, but they can't be on student council. So yearbook only, correct? So how many would that be? Yearbook and not student council would be the Crescent Moon. Let's just say. And then everyone's favorite, student council or yearbook. What shape is or? The snowman. Is it the snowman with his stomach as well? We talked about this yesterday. Yes, if you take out the snowman's stomach, you have a lump of snow on the ground. You do not have a snowman anymore. He just crumbles. He's a disaster. So that means I need to add what numbers together? 12 plus 3 plus 7. So 22. Make sense? Whole snowman. Every number in the snowman we add. Yeah?
How come these ones don't have to be put in this February bracket?
Because we're not listing the people's names who are in those groups. We're listing how many there are. So yesterday, remember I told you when we were filling in those Venn diagrams, put dots behind the numbers? Because dots behind the numbers means that's the number 7, that's the number 3. These ones don't have dots, so that's not the number 12 and 3 and 7. That means there's 12 people here, 3 people here, 7 people here. If we wanted to do squiggly brackets, they would actually have to list the 12 people's names in that Venn diagram. So it would have to be like Ava, John, Sam. I ran out of names after 3 in the whole world. Maya. Yes.
So if there's no dots, it's you do this.
It's the number of them. Yeah. And then you don't have to. If there's dots or names, and how you'll know if it's like actually more than one thing is it's usually not just one number there, right? Like I would have 12, 1, I have an eraser in my hand. That is not an eraser. Look at that. That says pen. 12, 1, 3, there's already a 3 because that would be stupid, 36. Like they'll list more, right? Or they'll list the actual people's names. Like Todd, you know? Good old Todd. I should have had his wife name is Todd. I like that name. All right. Shoulda, coulda, woulda, but I didn't, and I'm not having any more. So there's that. All right. Let's go to 4. We have in a homeroom of 20 students. So what does that mean? There's 20 students total. I don't have any more to choose from. I can't find 21. Can't bring someone in from the hallway. I got myself 20 people. Okay? So that's my total. So that's my universal set of people. Did it list the 20 people? No. If it listed the 20 people, I would have a whole bunch of names written in circles. Correct? Okay. So there are 20 students. 15 take math. So I go 15, and they take math. So they're going to be in the M circle. Does it say math only? Does it say math only? Or does it say math? It says math. So could some of these people be taking social as well? Yes, it doesn't say math only. So we have to watch ourselves. If it's math only, it goes in the crescent moon, we're golden, right? It doesn't say math only. It says math. And then there's 12 that take social. So there's 12 in the S circle. You cannot fill in the social and the math until you filled in the eyeball in the middle. Because we need to find out how many people are in both so that we can find out how many are in only social and math to fill in the crescent moons. Correct? So let's keep reading. 10 take math and social. That's good. We need that. 10 take math and, thanks, board. I'm going to fight in terms near the board area soon here. Math and social. And is what shape on a Venn diagram? The eyeball. The eyeball has to be filled in before you fill in any of the circles. Note to self. You have to fill in the eyeball, the overlap, before you can fill in anything else. So let's go draw ourselves a Venn diagram. We have a box. The reason why we have to have a box around the Venn diagram is that has to encompass all of the 20 people, correct? Because there might be people who are not in math or social. They're not just going to float outside the circles. They're going to be contained within the universal set, the box, the 20 students, okay? Inside there we have two circles. We do not short form and put an M and an S. The only way you can put an M and an S on that Venn diagram is if you say, let M represent math, let S represent social, then you could put M and S, okay? If you don't put let statements off to the side, you will have to write math, social. We have to start with the eyeball first. If they don't give us the eyeball, we have to figure out how to get the eyeball. Did they give us the eyeball? Yes. They said in this class of 20, 10 take both, correct? I have to fill that in first. So there are 10 people already taking math in this Venn diagram, yes? There are also 10 people already taking social in this diagram, are there not? There's already 10 in there, yes? 10 people have been claimed. So, I have 15 people taking math. People will put 15 here in the crescent moon. Well, that's 25. I have a total of 20 students. Do we have an issue? Yes. There are 15 people. We have to think about this in our heads. There are 15 people. Remember, we're learning Venn diagrams, so you're not going to get this right every single time. You haven't even learned it, right? We're just learning it. Way through it. There are 15 people who take math in total. Yes? Out of that whole class. Currently, there are already how many taking it? 10. So how many take math only? 5. You have to remember to subtract. Do you see why I have to do the middle first? If they said 15 take math only, I can go put a 15 right there at any point in time. But they didn't say only, they said take math, correct? So there's already 10 taking math. So in this one, I have 5. In your Venn diagrams, you cannot show mathematical work. So I couldn't go here and go 15 minus 10 and put a 5 here. I can't show the work 15 minus 10. If I want to do 15 minus 10, I have to go off to the side and go 15 minus 10. Okay, that equals 5. And then I go put the 5 in there. You can't show the operations within your Venn diagram. Okay? Because remember, you need to know what the heck the different things mean. If there's not a dot there behind the number, that means that's how many there are there, right? If you have operations in there, then it gets confusing. Which of this is like operations, which of this is the actual answer, all that stuff. Yep.
Are you looking, just like, are you going to be marking if we do like 15 minus 10?
I'll be looking for the right answer. Yeah. All right. Social. How many are currently taking social in our Venn diagram? There are 10, and then there are going to be how many taking only social? 2. Because we already have 10 taking social. They have to be taking math too, because they're really cool. But there are 2 that take only social. Because if I count that whole social circle, I now have how many people taking social? 10 and 2. How many do I have taking just social? Like social total? 12. How many do I have taking social only? 2. Because they could ask that question, right? How many kids have claimed to fame that they're taking social or math? Which is the snowman. 17. So I'm done? No, what do I have to remember? Yeah, there's 20 students. So how many are taking neither of those? 3. More often than not, people forget about that outside number. They forget to do it. Okay? Remember, the universal set was 20, right? So I need to have 20 inside that box. That's when we draw a box. Okay, then we can answer any questions. So this one says, how many students take neither math nor social? How many? 3. Guess what? I'm gonna like give you like my layout of land here. This curriculum has been around since 2012. Was the very first time it was actually came out. Okay, we're in 2024. That is 12 years. I often teach this 2 to 3 to 4 times a year. That's a lot of times teaching this. So I can say that I'm pretty much can figure out where you're going to make oopsies, right? Do you know how many people, when the question on here says how many students take neither math nor social, They draw a Venn diagram and then they're done? Have you answered the question at all? If you are done and you don't put anything down here, are you assuming that I need to do the work to find out the answer? Would you say that that's what you're assuming at this point? Because you'll say, well, the answer is there. It blatantly is 3. No, it's not blatantly 3. It could be 3, it could be 5, it could be 10, it could be 2, it could be 15, it could be 12, it could be 17, right? You just drew me a Venn diagram. Did you give me an answer? No. There will be people, I would say a quarter of you at least, who will just draw Venn diagrams and not give me answers. And because you know the answer is 3, because you're like, but Mrs. Lepp, the answer is 3. It's outside the circles. If you don't write 3, then I actually have to know it's 3 and it's outside the circles. And that's on I'm not testing my math skills. I'm testing your math skills to know if you know it is. And some of you will say, well, of course it's 3. It's not of course it's 3. Because sometimes I'll say, okay, well, what is the actual answer to that? Some people will say 2, 5, 15. I'm like, well, then you didn't know, right? So I can't say, oh, I'm sure they know it's 3. They drew the Venn diagram. I can't. You have to actually answer it. And you will get deducted on a diploma if you do not. So what is the actual answer to this? 3. Do I just write 3 and put a box outside? No. And I told you this. In 30-2, you don't like word problems, you will adapt. And you will decide to not dislike them. And you will not have panic attacks when you see them, because 90% of the curriculum in 30-2 is word problems. They're all like this. So the great thing is you get over word problems being a problem for you, because that's how it is. And they're not bad, right? People see word problems get a little panicky though. It's just like a thing in your soul. You won't anymore, because you'll see so many of them. So the answer is 3. The answer is 3, and my English was really bad in high school, and I could still write sentences. Because all you do is recite the question. You just rewrite the question with the number in it, right? So this one says, how many students take neither math nor social? You'll say 3, and then you rewrite that. Students take neither math nor social. You could make it in a little cloud, you could box it, you could even just leave it without a box. But the sentence needs to be there. Because that's the only way I know, and the person who marks you for your diploma, who doesn't know you, doesn't love you, they can't figure out who you are, because you're in a booklet, which the booklet does not have your name on it. Like, they literally could. If you wrote, hey, Mrs. Lepp, how you doing? And I was marking it, I'd have to hand it to someone else if I knew that you were one of my kids. We cannot mark our own students if we see that it is. Like, if you wrote a note in there, and you're like, hey, Mrs. Lepp, I'd be like, here's my kid. I can't mark it. Okay? So they can't be like, oh, that kid is a 95. They know it's, no, they can't. They have no idea, right? They don't know what you know. So when we see the Venn diagram, we see 3 students take neither math nor social, we say, boom, this kid's got it. They know exactly what they found. They wrote a sentence. They know this. No question, nothing. 2 out of 2, right? That's what you want. You want no question about if you're right or not. We want all the marks. Okay. Can you guys put down your pencils? All right, so this is going to be super hardcore here. I really should use this. Okay, the last question was easy because easier. I wouldn't say easy. You just learned it. It's not going to be super easy. But the last question, they gave us the and. They gave us the middle piece, didn't they? That makes life substantially easier. You just subtracted off the other ones. But what if they don't give you the and? Okay? Everyone paying attention, because I can get most people, this is a question that comes up on tests, unit tests, finals, all the time. And if I get you guys paying attention right now, you guys think these questions are the easiest things ever, and you're like, I don't know why anyone finds them hard. Because you just have to understand it. Okay? So say this was a class of, oh goodness, this many. I really should have counted. This many, okay? Now, I tell you guys to walk up, and this one will have an M on it for math. Let's not do math and social, because you're all in math. This one has an S on it for social, and then these ones have, this pile is social, this pile is English, this pile is neither. Okay? We understand? Social, English, neither. So, I'm Thomas. I walk up here. I'm in social and in English. How many papers am I putting in? 2. How many humans am I? 1. So that's overlap. Do you agree? Okay. I'm Frankie. I walk up. I'm like, dude, I'm not taking science, social, or English. I don't have to write anything. And I put in the neither. How many did I put in? 1. And I'm how many humans? 1. Okay. I'm Samantha. I'm frozen. Samantha? I don't even know Samantha. No? Fine. I'm in social. I put in 1. I am 1 human. Spartacus is my name. I'm in social and English. I just put in 2. We agree? How many people just walked up? I think there's 4 of me. Okay, there's 4 of me. These are all my little tickets. There's 4 of me, right? So there should be 4 tickets, obviously, because there's 4 of me. I came up here. There should be 4 tickets. Let me count them. 1, 2, 3, 4, 5, 6. Wait a second. 4 people walked up, but there are 6 tickets. What does that tell me? 2 of the humans did what? Grabbed 2 tickets. So there were 2 that were in both. So if I have the people put in tickets for what they're in, right? And the neither. So if I have all the people put in the social tickets, all the people put in English tickets, all the people put in the neither tickets, and there's more than the number of people that walked up there, that's how many people were in both. Because they doubled up. They put in more than 1 ticket. So let's look at this question. Really aggressively catching in paper. So let's look at this question. I have a survey of 400 households. What does that number represent? Yeah. Yeah. The universal set, the number that needs to be inside the box. Okay? So I'm going to draw myself a box around here. And to help myself out, I'm going to put 400 out here to remind myself that 400 needs to be in that box. Okay? Told you we have to start off with the ends, always, the eyeball. So let's see what else they gave us. So 285 people said they had tablets. Okay? So there was 285 who walked in and said they had tablets. So if they walked up to the desk, they put in 285 tablet tickets. Right? Just like I did before. Yeah? Okay. Then 320 of them had printers. So then there was 320 printer tickets put in. Could it be possible, just saying this, could it be possible that Samantha walked up here and put in a printer and a tablet ticket? Because they have both. It's possible, right? Might not happen, but it's possible. In order to find out how many extra there are, we also need the neither people. There are 63 who have neither of these. They don't have a tablet or a printer. And guess what? I can go 63 out here. Can I not? How many people are left for those circles then? How many need to be in the box? In the box needs to be 400, correct? 63 are outside the circles. So how many are left for the circles? 337, right? We have 337 people left to complete the T and or T or what doesn't look like you. T or P. This one's done. 63. We already placed it on there, correct? So we agree. Did everyone agree that there are 337 people left to fill these circles? Does everyone agree with that statement? Is that a true statement? Everyone understands how we got there? There's 400 total people. 63 have neither of those things. I have 337 because I went 400 minus 63 to fill the circles. Yes? How many tickets got put in for tablets and printers? Add these up. How many tickets got put in? Ooh, I thought I had a color, but I didn't. 600 and what? 605 tablet and printer tickets got put in. Wait a tick. I only have 337 spots. How many extras? I have 337 spots, but I have 605 tickets. So if I take the 605 tickets and I subtract off the 337 people, how many people put in 2 tickets? Do the math. 268. Do you see what I'm saying? There were 605 tickets put in for tablets and printers, 605. There were only 337 people left though. So I have to take the number of tickets and subtract off the people left, and the overage of tickets meant that some of those people put in 2. And how many of those some people put in 2? 268, so that's the eyeball, that's the people who put in both. 268. Now I still need to label this. This would be tablets. No short forming. I don't know why this board hates. How do I find the people who put in only tablet tickets? Yeah.
Would you subtract 268 from the number of people who put in tablet?
Yeah. So there were tablet tickets. There's 285 tablets, right? There are already 268 tablets in here, yes? So if I go 285 minus 268, what do I get? 17? So there are 17 people who had tablets only. Then how do I find printers only? How many printers were there? How many printer tickets? 320. There are already 268 that happen to have tablets as well. So what do? I do 320 printers, subtract off the 268 printers that are already in here, and how many are left over? What's 320 minus 268? 52? Now, I should check always when I'm done filling in a Venn diagram that all of those numbers add to what? 400, or I made a new C, right? Every 2-circle Venn diagram needs to have 4 numbers. An outside number, the singles, and the and. So 4 numbers need to be filled in every time. 3-circle needs to have 8. 2-circle has 4. So when I add them up, I get 400. So now here it says, determine the amount of households that have tablets and printers. What shape is and? On a Venn diagram, what shape is and? The eyeball. Intersection. What number is that? 268. Tablets, but not printers. But not is the same as and not. So tablets and not printers. Remember when I have the and followed by a not, that's a crescent moon, correct? So this is another way. Tablets but not printers is the same thing as saying tablets only. How many tablets only people? 17. It's that crescent moon. Then we have tablets or printers. Tablets or printers. What shape is or on 2-circle Venn diagram? Snowman. So we count all 3 numbers, which we said was 337. Here's another one where I don't give you the and. I say there's 30 grade 12 students, 20 take math, 10 take physics, 4 take neither. How many take math and physics? So you're going to try this one out. You have to find the overlap. So this one said in a class of 30 grade 12 students. So I know that I have a Venn diagram. That Venn diagram has 30 out here to remind myself that inside of that Venn diagram I should have 30. 20 take math. 10 take physics. 4 take neither. So we have 2 circles. 1, 2. We have math. We have physics. Now, I always forget to say this because it's an assumption I make and I shouldn't. What I write, I expect you to write. So if I write math and physics and you're writing M and P, if I could just write M and P, I'd write M and P, correct? So if I'm writing math and physics, it's because you need to write math and physics. I'm trying to get you full marks. Yeah?
Could you make like a little
If you made a little legend and said, let M equal math, represent math, and P represent physics, and then you went M and P, you were 100% correct. But off to the side, you have to tell them what M and P represent. Yeah, that would be 100% satisfactory. We'd be happy with that. Yeah. Okay. So I know that 4 is in neither, so I'm going to go put a 4 out here. Which leaves how many students left for the circles? 26, right? Because there's 30 total. I take off the 4 on the outside, and I'm left with 26 for the snowman. We agree? So we go over and we say, how many tickets got put in? So I'm going to go over and start counting my math tickets. See, I can put ends on some, and then I got lazy and stopped. I forgot to like 16. But I got 20 maths, and I'm okay, cool. I'm going to go 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And I count up all of the physics and all of the math tickets, correct? And when I count them up, I get 30 tickets. Don't write tickets on your diploma. They're going to be like, tickets? What is this person talking about? In my head, I see them as tickets. You can see them as however you want. But if I count up all the tickets, there are 30. But how many students are left for the snowman? There are 26 students left for the snowman. So if there are 30 tickets, but there are 26 students, how many of those students overlapped? How many of those students put in more than one ticket? 4. 4 are in math and physics. Do we agree? Does that make sense? We're going to practice it a lot. Don't get me wrong here, but if I can get at least half of you to make that make sense right now, I'm winning. Okay? So, I put 4 here. There are 4 that are overlapped. So how many took math only? 16. How'd you do that? 20 took math. 4 are already taking math. So that means 16 took math only. Physics, there are 10. There are 4 already taking physics. So that means there are 6 taking physics. If I add them up, what should they add to? 30. So let's do it. 16 plus 4, 20. 6 plus 4, 10. 20 plus 10 is 30. We're in good straight. So then we're done and we move on to our next question. Oh, we didn't answer a question. We did a Venn diagram. Lovely. A great Venn diagram. Super proud of it. It's awesome. Didn't answer the question at all. So it says, how many students take math and physics? So you would say 4 students take math and physics. We agree? The other question that they say, so if they ask how many took math and physics, it's kind of a giveaway that you need to find math and physics right away. Sometimes they'll make it a little harder by not asking directly for math and physics. They'll ask for how many took physics only, or how many took math only. And you can't find them unless you find the and, right? Because you can't actually find the singles until you you find the and. So if they ask that, how many took physics only, you'd say 6. How many took math only, you'd say 16. Right? Okay. Go. All right. So in an Alberta school, there are 65 grade 12 students. So once again, we have that 65 on the outside, because that's our total. Of these students, 23 play volleyball. 26 play basketball. Could people be playing both? Yes, in our school we have people who play volleyball and basketball. Okay, there can be overlap. All right. There are 31 who do not play either. 31, neither. So that goes on the outside, correct? We put the 31, it's neither. Then we go off to the side here and we find out how many are left for the snowman, correct? So we subtract 31 from our total and we're left with 34 left to play the sports in the snowman. That's 34 people left. Do you agree? Everyone agrees? We're all in the same boat? How many people said they played the sports? How many tickets got put in? 49 tickets. But how many students are left? 34 students. If there are only 34 students left to fill that snowman, how many people put in more than one? How do we figure that out? 49 minus 34, which leaves us with 15 in both. And we can find the onlys by subtracting, correct? So there are 23 who play volleyball. So in the volleyball circle, there should be 23. If I do 23 minus 15, because there's already 15 playing volleyball, yes, playing basketball, cool, I don't care. There are 15 playing volleyball already. That means there are 8 who play volleyball only. There are 15 in basketball, but there are 26 who play basketball. So how many play basketball only? 11. If I add up all 4 pieces, if it is a 2-circle Venn diagram, there should be 4 pieces of information. If I add up all 4 pieces, what should they add up to? 65, because that's what we have sitting out here, a floating number, right? So I do 11 plus 15 is 26, plus 31 is 57, plus 8 is 65. So I know I'm in good stead. Then I can answer questions. Plays volleyball only. Well, if I went to do that in an actual set notation, volleyball only would be volleyball and not basketball, right? I'm just showing you the set notation so we keep getting that in our heads. That and not gets us the crescent moon, gets us the volleyball only. So volleyball only, how many play volleyball only? 8. Then we have basketball only. That means basketball but not volleyball, correct? Basketball only. So that's basketball but not volleyball. So that gets you that crescent moon when you have the and complement. So that's basketball only, which is 11. And then we have volleyball and basketball, which is how many? 15. And is always the eyeball on a 2-circle bed. We agree? Those were all numbers, correct? Now we're back to sets with elements in it, correct? So here we're going to have more than one number sitting in a region, correct? And those numbers are going to have little dots behind them to show that that's an actual number. That's a digit, not 2 people. That is the number 2. That is the number 3. That is the number 4. Okay? So in this box, I need to have all of those numbers. We agree? Because that's a universal set. I am going to have a circle that is A with some numbers in it, with little dots behind them. Now I have to check out, are A and B disjoint, which means nothing in common, or is there overlap? There's overlap, correct? So if they were disjoint, I would draw 2 separate circles sitting off by themselves if there was no overlap, correct? But there is overlap, so I have to draw myself a Venn diagram with that overlap in it. Put a B on it. Okay, I want you guys to try and fill it in and then answer these questions, okay? Try it out. See how you do. You don't have to do perfection, you're just trying, so we're using pencil. When you're done that, I want you to flip over. You're doing 9, 10, and that's it. And we're going through them tomorrow, and then you have some work in your workbook. So I want you to try 9 and 10 as well, please. Okay?